Assalamu alaikum everyone. Today we have an assignment in Microprocessor. The assignment said that we need to write an 8051 assembly program that calculate the sum or make an addition operation, which are going to be in some addresses. These addresses, when we do the assumption or we do the addition, we are going to send the result to port 0. And all this is going to be in the accumulator. We are going to use the accumulator and indirect addressing and the DGNZ instruction to write an 8051 assembly program that calculates the sum of the array. And we also need to make an array, and we need to assign values to make it easier for the calculation operation. And note to demonstrate step by step on the debug screen that your code worked correctly, assign random values, and that's what we will do. I already made a pre-code or PVD code that's here. Wait. So the code is started by an original address which is 00H or 000H. That's the original address and start of the program. And then we have the arrays. In the assignment, it specified that the addresses should start from 10H to 19H, which the total is going to be 10 addresses. So we have 10H equal to 5, 11H equal to 12, 12H equal to 3, 3H equal to 20, and by using the move addresses, we assign the 5 value into the 10H address, and the same for all of these addresses. So this is 5, 12, 3, 20, 9, 1, 10, 17, 7, and 2. And then we have the pointers. The first one is to assign the first addresses or the first address that the program should start from. And the second R0 is the counter. So the start of the addresses is really straightforward, but we use the counters or the counter R0 for the counter of the total of the number of the calculation we used with the DGNZ. So what this do is it decrease the value of R7 counter, which we specify as 10, decrease it by 1 until it reaches 0. For the DGNZ, it never goes to the next line or the next operation until the counter R7 reaches 0. So for the first one is 10. It decreases it by 1, 9. So it never goes to this one or the next line until it reaches 0. And then it goes again to the sum loop or addition loop until R7 reaches 0, which this make it a 10 calculation operation. And then we move the result to port 0 by using the accumulator. We use the accumulator to get the result from at R0. So what this do at R0 is that we specify R0 as the value in 10H address. So at R0, it get the value from the address in R0. So by this, we go in here, and then we go in here, and then add the value while we go to the next address. So now I will start the debug. We will move step by step, and for this program, we need to look at R0, R7, and 8. So next is for arrays to get assigned in the addresses. So R0 is 10H address, and R7 is 10. For the it is a hexadecimal hexadecimal uh, way of specifying numbers. For this, it goes to for the for the for the values, it goes to 10, and then it goes to 9, and then it goes to 8. So for this, A is 10, B is 11, and C is 12, and this goes on. And for the A, now we get the value at the address at R0, and it goes to A, and it's 5. We decreases, and notice here A goes to 12H. R7, which was 10, become 9. And A by the addition goes like this. And this have like for the hexadecimal, it has like a base of 16. So then R0 become 12, R7 will become 8, and A will become 14. And again, this is a hexadecimal, so base of 16. Okay, R0 13, 7, 28, 14, 6, 31, 15, 5, and 32. 16, 4, and 3C. For this, to know the real value, we need to do it for, like, we need to get a base. Need to know that it has a base of 16. So it is the real value is like 3 multiplied by 16 plus, because C here, we know that C is in hexadecimal, is already a base 16, which equal to 12. We don't need to multiply it by 16. So it goes like 3 multiplied by 16 plus C, which already is 12. So we get like a value of 50. I think 3 multiplied by 16, 8, 4, 12, yeah, 60. And then 17, then 3, then 40, also the same, 18, 2, 54, 19, which is the last operation, and the last address, 1, 56, 1A, which already the R0 will become 0, and it will go to the next line, and the result will be sent to port 0 from the accumulator, or A, and in the end the program will make an infinite loop, which is sjump, maybe $, like this. Thank you.